Hello friends, today you are going to discuss dynamic programming, and under dynamic programming you are going to discuss traveling salesperson's problem. You will be remembering that we have already discussed Watson's problem, Floyd algorithms, then knapsack problems, right? And similarly, we are going to discuss traveling salesperson's problem. As we can see that in real life, postman problem, what will happen? They will try to collect all the letters from the post office and they have to go and distribute those letters door to door, right? In order to cover less distance. When you are talking about the less distance, then less cost, right? Or you can say that lesser time. So what is the tendency is to complete the journey from the post office and complete all the task, okay, and return back to the post office to report, right? It means what source and destinations are remain same. So here in traveling salesperson's problem also, source and destinations are remain same. Say as for example, here we have city 1, city 2, city 3, city 4, right? Vertex 1, 2, 3, 4, or you can say that city 1, 2, 3, 4. Now, say there is a path from 1 to 2, there is a path from 2 to 3, 3 to 4, 1 to 4, 1 to 3 and 2 to 4. There is a path. Now, in this particular case, say source vertex is 1, means city 1. We have to start the journey from 1 again by visiting all the cities exactly once and come back to the source. Remember that intermediate vertex you are not going to repeat. Only we are going to repeat that is called source vertex. By starting the journey from 1, going through all the vertex, all the cities exactly once, come back to the same cities. Source, that is called traveling salesperson's problem here. Remember that here I have not mentioned any weight on their edge, right? If there is a weight, right, say here it is 5, 10, 7, it is 6, it is 3, it is a 2, then it is called weighted graph. It means in the real life what will happen? Distance from city A to city B. Either you are going to discuss in the form of distance, kilometer, right, or how much time it will take to reach, or how much amount of how much amount you are going to spend to reach from source to destinations, right? So that is why it's called cost matrix. So let us see that if source is 1, then how you are going to visit this remaining vertex 2, 3, 4 and returning back to city 1. There are certain way, if you are applying brute force technique, right, ordinary way, then we can say that 1 to 2 there is a path, 2 to 3 there is a path, 3 to 4 there is a path, and 3 to 1. We have returned back to 1. By visiting 2, 3, 4 exactly once, return back to the city, same city. Now that is called source. Or there is a chance we can go like this: 1 to 2, 2 to 4, just we do, and 4 to 3 and 3 to 1. 1 to 2, 2 to 4, 4 to 3 and 3 to 1. That is also possible. Now, there is a chance we can do 3, 2, 4, 1. 1 to 3, 3 to 2, 2 to 4 and 4 to 1. Or we can write it like 1 to 3, 3 to 4, 4 to 1, 4 to 2 and 2 to 1. So, this is a 4 combination. Now, what could be the next combination is, maybe from 1 we can go to the fourth vertex, 4 to 2, 2 to 3 and 3 to 1. And last will be 1 to 4, 4 to 3 and 3 to 2 and 2 to 1. You will see that these all are the 6 different combinations we are getting from source 1 by visiting all the intermediate vertex, come back to the same cities by applying brute force technique. Remember that if number of cities are more, then this technique is not going to help you out. Okay, even person is not aware of algorithm technique, they are applying the same technique called brute force. So brute force technique is another which is called direct method to solve the problem, a straightforward approach to solve the problem. right? Now, if you are able to place this distance, right, then you can find out among this some particular path is optimal path. Remember that these all are called, these all 6 solutions based on this graph is called flexible solutions. It means what? These all solutions are satisfied the condition of traveling salesperson's problem. But when you are talking about dynamic programming, it means we are going to apply dynamic programming in such a way that we will be getting optimal solutions. When you are talking about optimal solution, it means in flexible solutions there are one, or it could be 2 different paths will have the same distance. So optimal solutions is when in a form of distance lesser distance, in form of time lesser time. If you are talking about the with respect to amount, then we are going to spend the lesser amount to complete the task. So let us see that 1 to 2, what is the distance? Say 5 plus 2 to 3 is 10 plus 3 to 4 is 2 plus 4 to 1 is 3. So if you count this total, right, that is the distance for this particular path. 10 plus 5, 15 plus 2, 17 plus 3, 20. So this 20 is total amount or total weight from this source to source by visiting all the vertex exactly once. Similarly, if you are going to perform 1 to 2 is 5 plus 2 to 4 is 6 plus 4 to 3 is 2 plus 3 to 1 is 7. So if you see that 7 plus 2 is 9 plus 6, 15 plus 5, 20. Right? Similarly, if you are going to traverse this 1 to 3 first, 7 plus, here you can see that both are having the same cost. 3 to 2 is 10 plus 2 to 4 is 6 plus 4 to 1 is 3. If you will see that distance 17 plus 6, 23 plus 3, 26. See, among this 20 is minimum, 26 also we are getting, but that is flexible solutions. Similarly, if you will see for 1 to 3 is 7 plus 3 to 4 is 2 plus 4 to 2 is 6 plus 2 to 1 is 5. This is again 20. Similarly, 1 to 4 is 3 plus 4 to 2 is 6 plus 2 to 3 is 10 plus 3 to 1 is 7. So if you see that, again it is coming 26. Last is 1 to 4 is 3 plus 4 to 3 is 2 plus 3 to 2 is 10 plus 2 to 1 is a 5. So it is 3 plus 2, 5, 15 plus 5, 20. So this is one example I have taken. In this we have 20 is a minimum distance, and that is considered to be the optimal solutions. So here we have to analyze which is going to be the optimal solutions. But when number of cities are more, it can be the random, and we have to find optimal solutions by applying dynamic programming for the traveling salesperson's problem. So let us see that. As I said, your objective is to find optimal solutions among all flexible paths. You understood that what is flexible path and what is optimal solutions. Given the list of cities, the distance between each pair of cities, what is the shortest possible route that visit each city exactly once and return to origin city, that is called source city. Now we are going to apply this formula. This is the particular formula when you are starting the journey from 1, and V is a set of all the vertices, all the cities. So when you are talking about starting the journey from 1, then this part you can see that V minus 1, it means what? Set of vertex minus 1, right? In this particular case, you can see that if you are starting the city from 1, what are the cities you are going to traverse? 2, 3 and 4. So that is a V minus 1 is 2, 3, 4. Here V is 1, 2, 3, 4. Minus 1 is 2, 3, 4. Right. Similarly, mean of C of ij. C of ij is distance from I to j plus G of j intermediate vertex to V minus 1, that is source vertex, minus j is remaining vertex. So it can be 2 to number of vertex is 4 minus 1 minus 2. So we are going to find out either 3 or 4th vertex combinations. When you are going to generalize this, then we have to make G of is equal to mean of ij plus G of js minus j for all I not belongs to S. I not belongs to S. So we are going to use this and we will be able to understand why this formula is written like this. Okay. So let us see that, and we are going to use these two formula. This formula we are going to use it at the last. This formula you are going to use it for all the intermediate steps. Remember that here as you are writing ij, then j is a source is I, j is a destinations. Here j will come first, right? And here we are going to say set of possible vertex minus j, right? So let us see and understand how exactly we are going to perform. Let us see this. This is the example. If you are going to write this, how many vertex we have? 4 vertex we have, right? So say here we have 1, we have a 2, we have a 3 and we have a 4. If you are going to represent this like vertex number 1, 2, 3, 4, and here we have 1, 2, 3, 4, then we can say that 1 to 1, 1 to 1 is 0, 1 to 2 is 10, 1 to 3 is 15, 1 to 4 is 20. Okay. So 1 to 2, 1 to 3, 1 to 4. Similarly, 2 to 1, here we have bidirectional graph. 2 to 1 is 5. Just I am making you to understand how it is represented. It is bidirectional graph. It is not a, you can say that undirected graph, right? So 2 to 1 is done. 2 to 0, okay. 2, 0. 2 to 3 is 9. And 2 to 4, 2 to 4 is 10. Similarly, 3 to 1, remember that this is the path we have. 3 to 1 is 6. 3 to 2 is 13. And 3 to 4 is 12. Similarly, 4 to 1, you will see that 4 to 1 is 8. 4 to 2 is 8. And 4 to 3 is 9. So we can see that it looks very complex, and that is why we are having, weighted agency matrix. But it is just I am trying to show you that 1 to 2 and 2 to 1 distance are not same. So we will be getting here many possibilities. Now, point is to be noted when you are talking about some path, right? Then we can see that these all the vertex, we can see that 4 to 1, 3 to 1, 4 to 1, 2 to 1. What is the combination here? Either it is terminating with 4 to 1, 3 to 1 or 2 to 1. 1 is a source vertex, or you can say origin vertex. Then before that, whatever the vertex is coming is remaining set of vertex, either 2, 3 or 4. So first you are going to find that values. So how it will go? How it will go is, first you are going to write from here that this 5 to 1, okay, 5 to, either this is the one source, so 2 to 1 is 5, 3 to 1 is 6, 4 to 1 is 8. So first we are going to find out the graphical values like G2, 5. G of 3 comma 5. G of 4 comma 5. Why? Because we don't have any vertex. In set of vertex, we don't have anything 2 minus 2 is 0, 3 minus 2 is 0, 4, 5. Okay. This can be written as C of 2, 1, C of 3, 1 and C of 4, 1. At the beginning, to represent this 5, 6 and 8. So this value is 5, this value is 6, this value is 8. In similar way, when you are going to find combination of two vertex, combination of two vertex means what? What will happen? Either you are going to find out, right, here 2, 3, right, 2, 4, 3, 4, 3, 2 combinations. So let us see that second general form. We are talking about 2 and here set of vertex will be there. So let us see that. G of 2, 3, right? If you are writing this, then what will be the, based on the formula, all of you please, G of, I have written 2, 3, so 2, 3, so 3 is a set. If you are going that, so 2 from the set J, 2, 3, C of 2, 3 plus J will come here 3, S minus J, 3 minus 3 becomes 5. So let us see that I am going to implement this formula. G of 2, 3. So this is here I, this is S, right? We are going to write C of I, J, 2, 3 plus G of, when you are writing the G of this J means 3 will come first. This 3 will come first. So G of 3. And here you can see that S minus J, what was the number of element was there in the set minus J element. It means here J we have a 3, S minus J, 3 minus 3 becomes 5. That is a set. In a set we have only one element called 3 and 3 minus 3 becomes 5. Hence it is 3, 5. Okay. Now we are going to find the values. C of 2, 3. C of 2, 3 from the graph. C of 2, 3 is a 9. C of 2, 3 is 2, 3 is 9 plus G of 3, 5. G of 3, 5 we already computed is 6. 9 plus 6 is 15. Alright. Similarly, we are going to find out G of 2, 4. Similar way, you can compute 2, 4, I, J. So, you are going to write C of 2, 4 plus G of J, 4, comma, 4 minus 4. There is no element left. So, C of 2, 4 is C of 2, 4. Second row, fourth column. 2, 4 is 10 plus G of 4, 5 from here. What you already calculated in previous iteration is 8. So, it becomes 18. Similarly, we are going to compute G of 2, 4 is already 2, 3 is done, 2, 4 is done. So, what is next? We can go 3, comma 4 calculations. We will go 3 and 4. What is that? C of 3, 4 plus G of 4, 5. So, C of 3, 4, 3, 4 is 12, 4, 5 is 8, so it is 20. Similarly, we are going to find out G of 3, 2 is equal to C of 3, 2 plus G of 2, comma 5. C of 3, 2 value is 13 plus 2, 5 already calculated is 5. 13 plus 5 is 18. So, we are done with the 2, 3, 2, 4, 3, 4, 3, 2. Right? Remember that here first parameter is I, second parameter is S. Since we have only one element and we have to select the element from here. So, from S, if you are going to select 3, so S minus J, 3 minus 3 becomes null, 5, empty set. So, we are writing empty set. Since empty set you have already defined either 2, 5, 3, 5, 4, 5, their value is there, 5, 6, 8. So, you can use that values. Similarly, we are going to find out another values called G of 4, 2. If you are writing G of 4, 2, C of 4, 2 plus G of J is 2 and there is no element left. So C of 4, 2, we need to see that values. C of 4, 2 is 8. So it is 8 plus 2, 5. In previous citations, we can see that 2, 5 is 5. So we are writing here 5. So here we are getting 13. Similarly, G of 4, 3 you are going to calculate. In that case, we can write C of 4, 3 Ij plus G of J becomes first parameter 3 and 3 minus 3 becomes null. It is a 5. Hence, 4, 3. We need to check that what is the value of 4, 3 is 9. Okay. So you are going to write 9 plus G of 3, 5. We need to see that what values you have computed. 3, 5 is 6. So 6. 9 plus 6 is 15. Remember that we have already calculated all the combinations 2, 3, 2, 4, 3, 2, 3, 4, 4, 2, 4, 3. Right? So single combinations we have done. What is next? We are going to find out double combinations. Right? And what will be that? We are going to find out G of 2, 3, 4. In this set we have 2 elements. Okay? In this set we have 2 elements. Similarly, we can have G of 2, 3, 4 combination is done. No need of doing 2, 4, 3. Okay, because it's going to represent the same things. I will let you know. Similarly, we are going to find out G of 3, 2, 4 combinations. Right? And one last we are going to compute G of 4, 2, 3 combinations. So if you are doing, we will be getting some values that will give you little bit ideas. Now, what is the outcome of this? Outcome of this is either it will give you 2, 3, 4 combination. Either path is from 2 to 3, 3 to 4 or 2 to 4, 4 to 3. Here path will give you 3 to 2, 2 to 4 or 3 to 4, 4 to 2 combinations. Like this, we will be having all possibilities here. Okay. And that is why since we have 2 values, we are going to use mean function. You will see that here we have a mean. So among these, we are going to find out mean function because remember that our goal is to find optimal solutions. So let us see that. We are writing here mean. Now this is I to j, 2, 3. First time we will take 2, 3, I, j plus G of 3 is a j. So 3 will come first. Now we have a set element is 3 and 4. So set element S minus j 3, 3, 4 minus 3, left out is only 4. Left out is only 4. Got the point? Again I will tell you, this is I, this complete combination is S. From this we got the option, either you are going to select 3 or 4 as a j. So first time I have selected 3, so left out element is 4. Second time, so these values we are getting, now we have a comma and we have C of, next time j value change, C of 2, 4 plus G of 4 comma 4 is cancelled, 4, 3, 4 minus 4 is becomes 3. So we have a 3. So among this, which is the minimum values? Look, 2, 3, 2, 4, right? And with these values already computed in the previous iterations. So let us see that. You are going to write mean of C of 2, 3. What is the value of C of 2, 3? C of 2, 3 is 9. Right? Plus G of 3, 4. If you see that G of 3, 4, 3, 4 is 20. Here we have 20. Comma. C of 2, 4. C of 2, 4 is 10. Plus G of 4, 3. G of 4, 3 already computed is 15. So among this, 20 plus 9 is 29. 10 plus 15 is 25. Right? So we are getting here minimum values is 25. And which is minimum values? This part is giving minimum values. This part is giving minimum values. So just we have underlined it. Okay, I will tell you why we have underlined it. Okay. Now, Next is G of 3, 2, 4 we are going to compute. In similar way, we are going to write mean of C of 3, 2 plus G of J is 2, so we are going to write 2, and 2, 4 minus 2 is remain 4, comma C of 3, 4, C of 3, 4 plus G of 4 is J, 4, and this is 2, 4 minus 4 is 2, right? So, based on this, we are going to find out the minimum values. So, mean of 3, 2. What is value of 3, 2? 3, 2 is 13. So, this value is 13 plus G of 2, 4. You will see that 2, 4 we have already computed, it is 18, comma C of 3, 4. C of 3, 4 is 12 plus G of 4, 2 already computed is 13. So, in this part 18 plus 13 is 31, 12 plus 13 is 25. So, 25 is lesser. So, 25 is lesser, and this part is given the lesser values, hence we have underlined it. Alright. Similarly, we are going to find out the next values. Mean of 4, okay, C of 4, 2 plus G of 2, comma 2, 3 minus 2 is 3, comma C of 4, 2 is done, 4, 3 plus G of 3, comma 2, 3 minus 3 is 2. Just apply the values. So, mean of C of 4, 2, just go and check, 4, 2 is 8 plus G of 2, 3, we already computed earlier, 2, 3 is 15, comma C of 4, 3 is C of 4, 3, 4, 3, C is a cost, so direct path, 4, 3 is 9, C of 4, 3 is 9, and plus G of 3, 2, we already computed earlier, 3, 2 is 18, 3, 2 is 18, so we have 18. Now, here 15 plus 8 is 23, 18 plus 9 is 27, so 23 is lesser, so we have underlined it, we have underlined this, and we are writing here 23. Look, here we are getting 25 minimum, 23 minimum. Now, remember that here combination of 3 is done, which is, what is element is missing here is, that is called 1. So, now we are going to use the first formula. You will remember that first formula is start from 1, and V is all the set of vertices except 1. So, we are going to apply that and see that what is the final. So, let us go and find G of 1, 2, 3, 4. If we do that, then we are going to write here as per the formula, mean of C of first is 1, 2 combinations, 1, 2 plus G of 2 is J, and if you subtract 2, 3 minus 2 is 3, 4. Similarly, now 1, 2 is done, 1, 3, we will go with 1, 3 plus G of J is 3. Now 2, 3, 4 minus 3 is becomes 2, 4. Similarly, we have one more thing called C of 1, 4 combinations plus G of 4, 1, 2, 3, 4 minus 4 is 2, 3. Right? Now let us see and apply the values. We are writing here mean of C of 1, 2. If you see that values, C of 1, 2 is 10. C of 1, 2 is 10. So this value is 10 plus G of 2, 3, 4 we already computed. 2, 3, 4. What is minimum values? Is 25. G of 2, 3, 4. Minimum values is 25. So we are going to apply these values 25. 25. Similarly, C of 1, 3. C of 1, 3 is 15. We are writing here 15 plus G of 3 to 4. What value is G of 3 to 4? 3 to 4 minimum value is 25. So let us see that 25, comma C of 1 4. C of 1 4 is 20. Is 20 plus G of 4 to 3. G of 4 to 3. 4 to 3 minimum is 23. 23. Now here if you see 10 plus 25 is 35. Here is 40 and here is 43. Among this 35 is minimum. 35 is minimum. So we got 35. Now 1, 2, 3, 4 all the combination is done and we are getting 35 is minimum. Now how to backtrack it? What is the final path? So let us see that. Focus on this. From which component we are given 35? This component is given 35. Minimum values. Highlight it. Now what is the cost here? C of 1, 2. Cost is 1 to 2. Now this part is done. C of 1, 2 is done. Now we go and find G of 2, 3, 4. G of 2, 3, 4. Among this, which is minimum? This part is minimum. Highlight this part. This is the constant part. G of 2, 3, 4. So we have 1 to 2 is done. Now 2 to 4 is done. Based on this, 2 to cost is 2 to 4 is done. Now we are having it here. G of 4, 3. Go to G of 4, 3. Here is G of 4, 3. Here you can see that cost is 4, 3, right? So we are going to write it again 4 to 3. Now let us see that. G of 3, 5. So go to G of 3, 5. What is G of 3, 5? G of 3, 5 scale. Okay, it is C of 3, 1. C of 3, 1. So now we are going to write 3, 1. So this path is giving you 35. Let us see that. As per that diagrams, graph 1 to 2 is 10 unit. 1 to 2 is 10 unit. 2 to 4. 2 to 4 is 10. 10 plus 4 to 3. 4 to 3 is 9. Plus 3 to 1. 3 to 1 is 6. So if you add this, this will give you 35. Right? So this and this is the part of optimal solutions, and this is called traveling salesperson part, TSP solution. Alright, and let us see that time complexity is n minus 1, 2 to the power n minus 2. Okay, it can be generalized as a n into 2 to the power n. Reason is, right? In asymptotic notations, we have learned that if it is nearby general values, you are going to simplify it into the general values. Now, by this, because 2 to the power n is, it is a total subset, total number of subsets you are going to find out. And n minus 1 is total number of, iterations, you can say that 1, 2, 3, 4. If 1 is a source vertex, remaining 2, 3, 4, you are going to iterate it. So, n minus 2. And multiply by, for that combinations, how many number of subsets we have, because we are going to find out the values based on the subset. So if 1 is a source, remaining 2, 3, 4 is another vertex in that particular set, and we have how many different combinations will be having, 2, 3, 4. In this, we are going to find out all set of combinations. But if you are applying the brute force technique, what you have discussed in the beginning, these possibilities, then you can see that 1, 2, 3, 4, where 1 is a source, then 2, 3, 4. How many vertex you have? 3 vertex. So 3 factorial is 6. So 6 different paths will get it. So we can see that here we have 6 different paths when source is 1. right? So it is nothing but n minus 1 factorial times we are going to perform the task, right? So n minus 1 factorial. So if we'll compare with the dynamic programming, then time complexity is lesser because it is exponential 2 to the power n. So generally 2 to the power n having lesser order of growth than n factorial, and we have already studied in asymptotic notations. Finally, summary: the traveling salesperson problem TSP is a problem in combinatorial optimizations. When you are saying combinatorial optimizations, it means what? Here we are going to apply permutations, combinations, right? And as I said you, in brute force it's taking n factorial, and while in n minus 1 factorial it is close to n factorial, and if you are applying dynamic programming, it will give you exponential complexity. Has several applications such as vehicle routing problems, logistics, planning and scheduling. In dynamic programming, many decision sequences may be generated. It helps optimize and minimize the cost of last mile deliveries, right? So, as I said, you traveling salesperson problem is very close to postman problem or delivery person's problem, right? Who are going to deliver day-to-day life, they are going to deliver any product, whether you are saying that Flipkart, Amazon product, or food product, right? So that tendency will be there to complete the task in lesser amount of time or lesser cost, correct? And by covering lesser distance. So this is all about traveling salesperson problem. Thank you.